So, in last class, we have discussed about what is Gauss law and proof of Gauss law. In today's class, we will discuss about derivation of Coulombs law from Gauss law. Okay. Let us consider a spherical Gaussian surface with a charge plus q at the center of the sphere. Then the magnitude of electric field intensity is directed radially outwards. This is the direction of E. Yeah. Consider a small element area ds on the surface of the sphere, which is directed radially outwards. Okay, this is the direction of ds. So let us consider a spherical Gaussian surface with a charge plus q is placed at the center of the sphere. Then, since r is constant, this is r, okay, radius r. Since r is constant, so magnitude of electric field is same at every point on the surface. Okay. Then the magnitude of electric field is same at every point of the sphere. It's same at every point of the sphere. Okay. Consider an element area ds. See the small element area ds. Consider an element area ds on this surface. Then E and ds at any point on S are directed radial outward, because this is the direction of electric field. Since it is positive charge, the direction of E is radial outward, and this is the direction of ds. So E and ds are parallel to each other. Okay. Hence, electric flux through the small area ds is given by d phi E equal to E dot ds. Equal to, since E and ds are parallel to each other, okay, since E and ds are parallel to each other, so E dot ds equal to E ds cos 0, that is angle between them is 0. E ds cos 0 equal to E into ds. Okay. Therefore, the net electric flux so the entire Gaussian surface the entire Gaussian surface is given by phi E equal to integration of E dot ds. Okay. Equal to E dot ds equal to E ds. This is equal to integration of ds. Since E is constant throughout the sphere, so we will take out of the integration or E into ds. Okay, or phi E equal to E into integration of ds is surface area of the sphere equal to 4 pi r square. Okay. Where integration of ds equal to for a sphere. Alright. This is your equation 1. Okay. But according to your Gauss law, according to Gauss law, phi E total electric flux is equal to 1 by epsilon 0 times total electric plus by closed surface is equal to 1 by epsilon 0 times the total charge enclosed with the surface. Phi E equal to Q by epsilon 0. Okay. This is your equation 2. Okay. So from equation 1 and 2, so from equation 1 and 2 into 4 pi r square equal to Q by epsilon 0 or E equal to 1 by 4 pi epsilon 0 into Q by r square. Okay. So this is the expression for the magnitude of electric field intensity due to a point charge. Okay. So equation 3 is the expression for the magnitude of electric field, the magnitude of the field placed at a distance r, placed at a distance r from the charge plus q. Okay. So the point charge is placed at point P. If we place a test charge plus Q0 at this point, if we place a test charge plus Q0 at this point, at point P, take at point P. Okay. We place a test charge at this point. Let the point B will be P. Point P. And here a charge is plus Q0 is placed. At this point, a test charge is placed. Then what is the force acting on the charge? Okay. If a small test charge, if plus Q0 is placed at this point, okay, point P, then the magnitude of force acting on Q0, then the magnitude of force acting on Q0 is given by F equal to, okay, force acting on a test charge in a uniform electric field, F equal to Q0 into E equal to Q0 into E is found to be 1 by 4 pi epsilon 0 Q by R square into 1 by 4 pi epsilon 0 into Q by R square. Okay, from equation 3. We will put the value of E from equation 3. So this is equal to this is equal to 1 by 4 pi epsilon 0 Q into Q0 by R square. Okay. Take it equation 4 and this is your equation 5. Which is, okay, this is your equation 5 is nothing but also Coulomb's law. Coulomb's law for electrostatics, which is Coulomb's law of electrostatics. Okay. Which is your Coulomb's law for electrostatics. Hence Coulomb's law is derived from Gauss law. Okay. Hence Coulomb's law is derived from Gauss. Okay, in this way we have derived the Coulomb's law of electrostatics from Gauss. Okay.